Okay, so I'll report for the core group, or subgroup that worked on the core specification. First of all, for those of you who were not here yesterday, when I introduced you all that were here in person into the repository and the organization on GitHub, we have a GitHub organization where we share all the work, the specification, the tooling, the extensions, which is called GitHub. You don't see that due to Zoom. GitHub.com/Fibora. That's the link you can follow, and guides you to the list of repositories that we have, and that's, for example, a specification, a list of extensions, tooling, packages, the CLI for validation, creating from GeoJSON to GeoParquet, GeoJSON validator, and data survey, which you're all still invited to fill. So the subgroup that I was working on was working on the specification, the code specification, and we had something prepared before so that we had something to start with, and discussed all the things that were in here. There is the separation into a collection and features. We focused on the features itself, so the encoding of the geometries. So the core schema right now, and it is released as 0.1.0 version. Woohoo! Yay! Contains a couple of core properties, and this is the first step, right? So that is the first version of it. It's meant to evolve over time, and you'll see from how the extensions will get adopted, what else might be potential candidates to be included in the core specification. The first field that we have here, of course, each boundary has an ID specified. What was not clear yet was how the uniqueness constraint works. That is now defined to be unique within the collection. In addition, we have a collection property that points back to the ID of the collection that includes all these features and boundaries. Then there are a couple of spatial properties, of course. The boundary needs a geometry, a bounding box, and an area. Area is the area of the field in hectares. We added a couple of further constraints here for sanity checks. Read up on that. Then we had a couple of temporal fields in here. Before that was called datetime and expires. We changed that. There is now two fields on determination of the geometry, which is the method and the datetime. So that is a boundary creation method with a set of predefined values that you can choose from, and the datetime, which is defined at the last timestamp at which the field did exist and was observed. So that are the core fields. And we defined two encodings. So that is the schema in the end, the core schema. And that can then be expressed in two different variants, either in GeoJSON or GeoParquet. This is open to extension in the future, so this can have multiple additional encodings if you want. And that's the core specification for now. There are tools around that simplify working with it, creating extensions. I think Chris will guide you later into how the extension ecosystem works, how the template works. What you can do for all the extensions for the specification itself, there are validators, so if there are examples in the repository, you can validate them. There are two tools, for example, right, so for example, in this extension here, you can run npm test, and that will do the following. It will check the all the readmes that you've written, whether that's valid markdown. It will additionally also test whether the GeoJSON examples are correct and whether GeoParquet is correct. The last part will not run on this computer here because I have some issues with the tooling in the background, but if you install it freshly, that should work. So it's now checking all the readmes, checks that the GeoJSON features are valid, gives you an hint at which might be invalid if there are invalid ones, and then at the end checks the GeoParquet, whether that's valid as well. There's also a command npm run create GeoParquet examples that would, because it's easier to work in the GeoJSON files for humans. You can work on those, create the examples in GeoJSON, run npm run create GeoParquet example, then it takes the GeoJSON and converts all the features in there into a GeoParquet file, right? And then you could provide that as examples as well. So that's a nice steps forward to creating either or updating the specification or creating extensions. Anything I missed?
I think that's it. I don't know, maybe even just for people online, just a bit about the philosophy of keeping the core small and.
Yeah, exactly. So we had a number of discussions yesterday also about what fields should be in core. We used the stack approach, keeping it simple at the beginning, just having a very small subset. You've seen it was just geometry, area, ID, determination fields. But everything else, there are, of course, much more things that you need for different use cases. For ML, for example, which we report on later. But we'll start these in extensions, evolve those and see what works and what people are actually providing and using. And then eventually, if that provides to be stable, we will see whether that is a valid use case for sticking in an example, in an extension, or whether we promote that into the core specification in the end, right? So that's an iterative approach over time. We'll see how that evolves. So we're starting small, just so that the entry barrier for people to provide data is relatively small.
Anyone online have any questions? Oh, okay. In the room?
So I'm gonna talk about extensions. I think originally we were thinking the extensions group and the core group would be separate. We ended up staying together a bit longer, which I think was good. Matthias covered the core. I think two things to highlight that came about, we got to a time in the core, realized there are many times that people care about. And so we didn't do any work on this, but we should have like a time extension that, I'm like less the expert on the particular things you want, but like, when does this field valid to? What's the start end? And there's like lots of different time things people care about. So that'll be a set of work to get lots of options for that. And then ID as well is one that, field ID from Bardo, which you'll hear a bit about, is one that we definitely want to get in there and promote, but we didn't think it's the core ID, and indeed in their system, it's not used as the core ID, it's the field ID, and then there's a bunch of IDs from national mapping agencies that they assign on their thing that are good to represent. So we kind of see IDs, like there's lots of different IDs to refer to. And so we see that extension, and we still have to do exactly how we treat ID. The core, but the core is meant to be kind of more flexible, easy to use, but also have some uniqueness to it. The AIML extension you'll hear about, lots of good work on that. And we didn't get super deep into like really mapping out the potential extensions. We kind of dove a bit more into making one, but kind of had some ideas. And then we had an even smaller group with Jason and Katie and I. They taught me about management practices, and we see a full set of management practices in there. And then we made a crack at a tillage extension, which I'll go into. In general, the extension, so Matthias did a bunch of this as pre-work, but it's a pretty cool system that's all set up. So if you make a new extension in this overall Fabo repository and you kind of fill it out right, it'll automatically show up in this list. My tillage list doesn't want to show up yet because I made it today and it's a nightly build, but it's sort of, ooh. Crash. There's my tillage extension. It'll sort of auto-populate there if you do it right. There's a bunch of great instructions on how to make this extension of every kind of step that you need. But yeah, the cool thing is most all the infrastructure is taken care of. I mean, it seems like a lot of steps, but a lot of it's really just like kind of 3 files that you need to put in that I'll show to you. And then the way you start it is this extension template. So it's a repository in Faboa, and you just click use this template, create new repository. If you do it into Faboa, it'll get into the stuff. You can start it on your own and we can move it to Faboa later, but that'll help people see it, collaborate on it. And yeah, these are sort of shared extensions. There's also the notion of if you just have data internally that you want to validate on stuff, you can make a private extension. You can have it like in the corollaries is stack, and stack we have a planet extension to validate planet data, which not all of our fields or attributes are appropriate to fully standardize. But the idea with this is like, let's get communities going where we standardize on particular things. And yeah, I see that as one of the main things it does is just let's get a common language of how we refer to these sets of attributes that you have in a database for agriculture fields, like, you know, it's more than just agriculture. Yeah, and especially people remote would love contributions here of making new extensions. And we kind of we'll aim to meet regularly and kind of coalesce and figure out what it is. We also try not to get like too bent up on like, is this core extension, have this deep discussion now, and like, you know, how many do you put in extension? How many fields your attributes do you put in extension? I think our guidelines sort of like 3 to 10 makes sense, but yeah, can work with it. So then the one we did was me learning about tillage. And so this is the extension that we came up with. It's got whether it occurred, and that's your sort of required field, did tillage happen or not. If it didn't happen, you kind of don't really need the rest. I don't think we made it conditional yet in terms of validation, but you know, but then it's tillage type, how many, the type that occurred. This one we definitely need feedback on, and we're not super sure about it because you can kind of derive a lot of that from the particular properties. So we're interested in feedback on that. And then depth, spacing, angle are kind of the core things in there. And so we released this extension a little more on how it works. There's a schema file that kind of defines it, lets you do things like we define angle has to be 0 to 90. So then the tools will validate, you know, if you put an angle of 200 in, it's gonna be like, no, that doesn't work. We could put more constraints in there as well to kind of really make sure the data can validate. And then we have a couple examples. You can take village examples. We kind of, this was first me hand tracing 2 of them. I can do it in PlaySmart, check it out. Jason put together a larger set of examples in the same area. And yeah, you can get this table and sort of see, you know, all the ones that went that are in there. And then we've also got GeoParquet. And yeah, the tooling will let you kind of generate the GeoParquet from the GeoJSON, which is nice. Put that into QGIS. So yeah, you can see the attributes there. I put up some planet stuff, it's a shade. This is in the last 3 months. And you know, the field is less clear there, but yeah, this was traced from that box that has undetermined date.
You're on GitHub.
Anyways. Okay, okay. Drag it on. Boom. And then, yeah, I was saying the most recent tenant ones. You don't see it so much. But in prior years, you can make it out more clearly. So yeah, it was pretty cool to be able to like go create this extension. It'll take more iteration and whatnot. And then, yeah, that's sort of the process to make extensions. So yeah, it was cool to ship some data. We didn't find any data that had this that we could share publicly. If anybody has something like that, I'd love to play with actually converting it. Yeah, I know a couple of people work in this space, so that'd be cool. And yeah, certainly happy for the feedback. This was a first pass, make pull requests. Yeah. You.
Let's see, who's controlling the room? 'Cause I
We
just-
got one more
Oh.
readout, don't we?
No, we're this is the order.
Oh, I'm sorry.
I want to stop sharing.
All right. And then I need to let myself. Okay. So I'm going to talk to you all about Source Cooperative, give everybody an overview of it, some like sort of core concepts of what it is that we're building with Source. And then I should say this up top and really emphasize, I can't emphasize this enough. You all use Source Cooperative to host data. So we've built it with the support of both Azure and AWS. We have free cloud hosting for open data. So if you have data that's openly available, and certainly for the kind of the purposes that we're working on here, if you have data that you want to share with collaborators within this group or externally, like we're happy to host it for you. And so I just want to show you what it looks like and explain some of the thinking behind it, and also some concepts of cloud native geospatial data that have informed the design. So I'm going to log in. Not that, you know, most of the experience you can have while you're logged out. But so this is the sort of radical concept that I've come to after working in open data for a really long time. I mean, I worked like most of my professional career in some way working around data sharing and so roughly over the past like 12 years working specifically on open data. The best way to open up data is to put files on the internet. That's the radical idea. You just put files on the internet. It's something that's pretty easy to do. This is a well-worn path. I mean, a long time ago, the way you would share data is you'd set up an FTP server, and you'd log into that server, then you download the data from the FTP server onto your computer. But now, you know, as the internet has become, you know, so pervasive, and we have massive multi-billion-dollar companies competing with each other to produce cloud capacity, it's really trivially easy to put files on the internet. The difference between the sort of old way of sharing data, though, and then what we refer to as the cloud native way, is that the old way would assume, and again, going back to the example of an FTP server, and also the way that many people still interact with data day to day, is that the concept is, I'm going to go get this data and I'm going to download the data from wherever it's hosted onto my computer where I have it now. That's the traditional way that we're all familiar with. What happens when you get a file on your computer is that your computer has a file system, and for a lot of people here, I know I'm preaching to the choir, but I know not everybody like really groks this because we just sort of take it for granted. The file lands on your computer, you have a file system on your computer that indexes everything that's on your disk and has an understanding of like what it's for. So if you download a doc, like a docx file or whatever, it's like, oh, that's for Microsoft. There's an understanding of what the applications are that interact with the data. This, as you might imagine, doesn't really scale, especially if we're talking about terabytes or petabytes of Earth observation data or billions of records of farm fields. So we're in this situation now where you can put
petabytes of data up on the web, up on the internet for people to interact with. And then the trick then is, how do you do that in such a way that people can interact with it, that they can find it, and that they know what to do with it, and that they can build things on top of it. And answering all those questions those are the questions that we're trying to answer when we talk about work on cloud native geospatial. So with all that preamble, let me explain what Source Cooperative is. We call it a data publishing utility. It's a service that we built to make it very easy for people to put files on the internet. That's it. So I'll show you an example of a data set. This is actually one from Planet that we like because it has a stack catalog. So I'll walk you through this, or the general features of Source Cooperative and why we built it the way we have. So if you look up in the URL, you'll see here. Where's the URL? Oh, it's behind. I don't know if I can fix that. No, I can't fix it. Anyhow, well, anyway. So there's a URL.
We see it remotely, so that's fine.
You see it remotely? Okay. Actually, I think I can fix this.
Just said okay.
We hit okay. There we go. Okay, so now we can see the URL. So a URL here in Source Cooperative, this is our domain. We have this notion of repositories. This right here in the URL is the owner of the repository, and this right here is the name of the repository. And so this is a pattern that's very similar to GitHub, where you have users. Those can be individuals or organizations. And then those users have any number of repositories. And so our concept of a data set that you would share is it would be encapsulated in a repository. And what a repository is a collection of files, and ideally a README file that provides documentation of that. Okay, you got 2 minutes. Oh, that's right. Okay. And you have a whole hour after that. Oh, that's right. Okay. So anyhow, so this is what a repository looks like. You can browse the files, and this is thanks to Planet. This is about 100 terabytes of data hosted here in this repository. Now, but rather than making people click through all these files and just kind of feel their way in the dark, Planet also created a great stack catalog, meaning there's a bit of JSON in there that describes what's contained in this repository. It's sort of repository level metadata. Because it has a stack catalog, we can click through and we can load up this data set in a stack viewer. Thanks, Matthias. And you can see oh, this is covering Europe. And we can see here, here's the time scale for this. And you can continually click down through the catalog to finer and finer points. And that will be represented here in the viewer, the stack viewer. And so, but really all I'm doing here is I'm navigating all the content that's in Source through a stack viewer, because the data that's in Source has been organized in such a way that we can do this. And this is roughly the model that we're trying to promote, is to show people, if you just put files on the internet, if you use standards that other people understand, it enables the deployment and the building of lots of different applications and different viewers and stuff into these objects that are just here on HTTP. So if you want to use Source, you can reach out to me. I'm very easy to find. You can also just write to hello@source.coop, and we can get you set up with accounts and stuff like that, so we can share data with each other.
You're doing a full deep dive.
Yeah, we're gonna do a deep dive later.
At 2?
Yeah.
So any questions for Jed now, knowing that there's gonna be another hour deep dive?
Save your questions for the deep dive. We want to hear the readouts. So, thanks.
Okay, so I'm just going to try and give you a very, very quick overview of Field ID service, which is something that we created and maintain at VADA. Before I do that, I guess it's probably necessary to explain what VADA, the organization, is. So I'll try and do that even quicker. So we originally started kind of like a kind of ag tech corporate startup in order to, out of Yara, big fertilizer company, with the objective of enabling pre-competitive data sharing across agriculture, because kind of Yara recognizes that it's just kind of one part of this wider ecosystem, and it's quite hard to really advance the transition towards a kind of more nature positive kind of food environment unless you collaborate much more and exchange much more data in the past. And after a long period of working out what exactly is the thing that we would work on, we kind of picked a couple of things, one of which is essentially like a data access repository and kind of discovery platform for soil data called Soil Hive, and a global field ID, which is basically an initiative to try to map all the fields in the world and give them a common identifier. And the reason to do that is there's a few different reasons actually. On the one hand, it's kind of about interoperability. So to be able to give very simple and consistent identifiers that deduplicates all of the kind of data silos, because almost every application that is used on farm, whether it's to do precision agriculture or, just like running a kind of like a content management system, or whether it's a ERP that's maintained by a cooperative or a retailer, or it's inside a food manufacturer's system, they all kind of have this reference to fields and they all do it in their own way. And so we're kind of trying to solve a couple of problems. One is that kind of identify a problem, because if you cannot identify something, you cannot measure it, as well as the kind of the problem of being able to actually obtain a kind of open access boundary that defines that area of land. And so the way that this thing works is it's essentially a piece of data infrastructure, kind of mainly oriented around an API, which maintains a repository of any boundary that you like. So that's the first part it does. It kind of provides a registry through which any boundary can be kind of registered if it is of any relevance towards agriculture. We assign it a common identifier. We deduplicate if kind of two different sources have referred to the same boundary, but each call it something different. And that is kind of like, that's what we call the open boundary registry. We then also create a kind of separate data layer, which is like a kind of default map of where the fields are, meaning only boundaries which are supposed to define the extent of a field and which don't overlap with each other. And this is kind of like a special data layer, for which we kind of give a second identifier, which is an actual field ID. This thing is designed to be something that can be used in place of a name. So a lot of kind of matching between sort of data sets that happens in the wild is really done by using names for things, like the actual name that the farmer gives to the field. It's not really done using UUIDs or exchanging polygons. It's very, very low tech. And so that is kind of what the aim of that identifier is something that you could easily, turn up to the weighbridge and be asked, where did this stuff come from? And you whip out your, Google Keep and you read off the identifiers, or you send it in a text message, or you communicate it over the phone. So this is the kind of, this identify by reference rather than by sharing files is the objective for that. But kind of as a byproduct of this process, we do create a global data set of field boundaries that don't overlap with each other, which can be used as a kind of a starting point or a reference for all of the other kind of analytics that you might want to run on top. And so we kind of started kind of building this out through by kind of preloading lots and lots of data from existing public data sources. So that might come from the land parcel identification systems that some countries operate and make open source or open data in Europe, but also by like preloading ML generated like field boundaries for like whole countries at a time, and creating fields from them. So that's kind of where we are today. We've got about 1 billion acres kind of in this data set. It's all available via the API. We're just in the process of putting a download button on the website, so you can just kind of download the data en masse. And yeah, that's kind of where we're at with it. One extra kind of important thing that's maybe good to focus on is that a lot of the data, kind of definition of what a field is, cannot be seen from space. So although this kind of like community is maybe focused quite a lot on remote sensing, and that's how you get very, very broad coverage. The reality is that there are kind of various crops and various locations for which you cannot see the outline of the field. Like it's underneath the kind of canopy of some trees, or the division of a field is more logical than it is physical. So it's that this is land that's managed by two different people, for example. And so it's necessary for us to build a mechanism for which end users, the people who actually know, who work on the land, be able to correct, map, right, and actually kind of feedback. And so that's what kind of a large kind of effort has been devoted towards, to trying to build relationships with private sector software developers who actually have kind of footprint in existing like ground truth data to be able to kind of unlock that and make it part of the overall kind of data ecosystem. So that's kind of where we're at really. And yeah, I think the main thing that we're trying to achieve now is we're trying to really open up this thing. It shouldn't really be a private sector initiative. It should be something which is more maintained by the community, and that's what we're kind of looking to transition towards the non-profit structure with kind of open governance to be able to kind of run this thing like for the whole world as a public good. So,
You talk a little about how you see Samoa fitting in.
right. So I mean, on a very practical level, I mean, we source and kind of ingest and publish lots and lots of field boundary data. So it makes sense for us to, you have a much smoother operation to be able to ingest data. If you can just say, here's a file, it complies to the standard, please put it there. And same on the distribution, we can make available lots and lots of field boundaries. It's like a big, very, very large data set of field boundaries that if you express it in the format, then like all of the other tools that are kind of within our ecosystem will work with it. So those are kind of two key ways we can probably contribute. Like we've faced the problem of what happens if you aggregate field boundaries from lots of different sources which have different metadata structures, and how do you actually represent like different identifiers and all of that sort of stuff. It's a problem that we've actually kind of directly faced. So I think we can kind of contribute like that. And yeah, we can obviously benefit from more collaboration and things like how do you assess quality and those sorts of things, and really kind of make the kind of the sourcing and filling in of the global map much more of a collaborative effort, because the kind of like academia, for example, is there's a lot that it can contribute, but it needs to be run as part of an actual piece of infrastructure that is like run every year and everywhere. Like, and that takes resources.
Awesome.
How many minutes was that?
It was perfect. Great.
Anything else?
Nathan.
Questions online?
Yeah, any questions? So Nathan comes up.
Like there's a question. There's a hand raised.
I do have a question. Can I ask a quick question? So it's a little bit unclear about the field ID and boundary relationship. Like, how do you link them by the given time point and geography?
Okay, so for us, there are kind of like three main data concepts. One is what we call a boundary reference. This is kind of like an opinion about a boundary, which is a specific instance of a geometry in a specific source, specific data set, which has specific metadata. So it's like, this is what, the French national LPIS data set from 2022 says. And it's kind of reproduced verbatim, like exactly what they say. That is what is kind of inside the data set. But then we kind of create a second record from it, which we call a boundary, which is a deduplicated version of that geometry. So any references, there might be more than one, which refers actually to the same geometry. We give that a canonical identifier that is guaranteed to be the same, no matter where that geometry comes from. So it's like globally unique across all geometries everywhere. And then there's a third object, which we call a field, which is actually not a spatial object. It's more of a kind of semantic concept, which is more like a container. It's like the kind of thing that farmers use as a name. Like fields stay the same, even though season to season, the boundary slightly changes. And like, that is just a fact of the way that kind of the world works. And it's still necessary for a lot of the kind of supply chain to have an identifier that's much more stable than a spatial kind of concept. And so the way that we link these things together is that for each field, there is always exactly one boundary that defines the field's spatial extent for a given period of time, but that this can be changed, up to some level. You can also do things like splits and merges that are kind of represented inside this kind of ledger, if you like. And then there's a kind of like we compute the spatial relationships also between different boundaries so that it's possible to explore it like a graph, to be able to understand without having a GIS system that, well, this thing that's in the French LPIS system is 96.4% the same as this thing, which comes from the farm management system. And that thing is what we want to use as the definition of a field. So it's kind of helping you to actually navigate through like all of this data, which might have kind of come from different like disparate data sets, and understand how they all piece together. I hope that answers the question. It's quite complicated.
Awesome.
Yeah, answer the question? No, there's another question.
Oh. More questions?
Ariel.
Yeah, hi. I have one, just to clarify, sorry, because I know this is complicated. So is the ID persistent over time? Like if the boundary doesn't change?
Yes, so the idea is that the field, there can be many, many boundaries that are used for different purposes, all of which deserve their own identity. The boundary that was used to harvest in this season, you might have a planting operation, a replant, a spraying, fertilization event, harvest event. Each of these has completely different geometry. Those things are like boundaries, and we kind of give those very, very deterministic identifiers that's defined by geometry. But at any one moment in time, there's one boundary that's special. And this is the one that's kind of used to say, if something is inside this boundary, it relates to this field. And if it's outside this boundary, it is not related to this field. And that is kind of its pure purpose. And that means that you can change that boundary. If you say, I now have a better representation, a better geometry file, right, that defines this field, because maybe I started with one that came from machine learning algorithm. Now I've got one from the farmer himself because he's driven around the outline of this field in an RTK assisted GPS sensor enabled tractor, which is way more accurate. And the field hasn't changed. Like, it's still the same field. We just have a different boundary. So yes, there's a kind of a relationship between the two things, which we kind of maintain. But yes, we allow them to be changed.
Awesome. Thanks so much.
Leave open, share my screen here. All right. All right, so what we sought out to do was to define a schema extension focused on the AI/ML ecosystem. And we had two scenarios in mind as we were thinking about this. One is that you might release a FOBOA set of FOBOA field. That should be good.
Oh.
Yeah, that was me, sorry. Okay, so somebody might release a collection of a FOBOA collection, and then we need to be able to use that to ingest into some pipeline for training a model that does field boundary detection. The other is that we might have an automated approach that is doing field boundary delineation, and we want to represent some of the outputs of that. And so those were the two things that we were thinking about as we were creating this extension. So worked on this with Hannah, Subhash, Lexi, Eddie, and Mia. And we went back and forth on a few different, we had a much larger list of attributes, and this is what we sort of settled on. I'm pretty confident that based on what we've heard, that there are some of these that are going to get absorbed into other pieces, but sort of feel like this is a nice set that would be useful for these scenarios. One is adding a little bit more detail around the creation method. So this could be a link to the algorithm that was run or something like this. Some additional information about the boundary type. So as we were sort of listening throughout the last couple of days, we heard lots of different definitions for boundaries. And so if somebody's going to train a model, they might want to take this collection and filter it and train only on a certain type of boundary. Verified from and verified until is essentially the extent, maybe this field is only valid for a year. And so if we're going to be collecting imagery that we're going to use to feed into the model, we only want to get imagery from that year to sort of form the basis of our prediction. The author or provider, we sort of debated on that for a little bit. A confidence measure. And so this would be the output of an algorithm that is essentially a confidence value that's associated with the particular field boundary prediction. A couple of attributes related to crop type and crop category. And the final two were sort of last minute additions, would be sort of explicitly defining the split that this particular field corresponds to, whether it's part of the training set, a validation set, maybe a private test set or a public test set. And then the other is a split index, the ability to say that, if we're going to do some sort of cross-validation kind of training where we can explicitly define which group that belongs to, so that if they're disparate groups that are working on this, they will know that they're running experiments in the same way, so that we don't have to define some spatial boundary that defines the region that is training and testing, and you end up with sort of confusion about exactly what belongs to what set. So that's the README. We have a schema defined in there. I think we have an example of that. It's still, we have not transferred this over yet, but yes, that's what we did. So happy to take questions.
Awesome.
Yeah.
What do you see?
What about the verification date times? Does this mean this is only present on truth data? Because the word verified to me means. Take that.
Yeah, so I think that the thinking for this, if this is an input, right, so that you might have like manually validated, someone's collected this data, there's a start and an end, to the extent of time that they're stating that this field existed at this extent. Similarly, if we were sort of predicting from a model, it's going to be the range of imagery that we used, or that, you know, even if a subset of the images that we used,
So actually,
where we think that's.
it's not for you.
That's all right, that's all right. I'm just gonna keep going either way. Yeah, so that was the intent for that. It sounds like there is potentially a timeline extension that is going to probably roll a bunch of these things into it. And so we sort of heard that and didn't go a lot deeper into this, but.
Yeah, no, I think that it might be that you take some of these out and be like, oh, author, maybe that can go in, you know, provenance and like times, maybe that can be lifted and put somewhere else. But yeah, I just firstly want to understand what it meant. Like,
Yeah, our intent was, so at some point, you're going to have to take this field and grab a bunch of images that are associated with that will then be used as the input to the prediction algorithm. So we wanted to be able to know what range of dates makes sense to grab imagery. That was the real goal. And so, yeah, we debated verified versus a few other terms for that.
but you would also use it for the output, because it looks to me like this model is intended to be used for input and output. And so to me, if you said verified until,
Yeah.
I interpret that to mean no, not I think.
No, exactly. So like I mentioned that at the beginning that we talked about this in these two contexts. It might make sense to split up those two as separate extensions, right? There's the like machine generated extension and the sort of, anyway, so yeah.
What do you see as next?
And what do we see as next? I think that the big thing that we need to do, I think, is to sort of see if we can work with the group of the talkers who've actually been pushing data into this and thinking about it, to see which of these things actually make sense. Because we were hoping to do that, we just ran out of time to sort of see if some of these things made sense based on the actual data that they're pushing in. So that's one thing, I think, thinking about different data sets and trying to push them into this format. The other is figuring out which of these things make sense to pull out somewhere else, so that we can simplify this a little bit. So, awesome.
Can I ask a quick question? Hopefully it's quick. So I see one thing is missing if, we submitted our field boundary is like field boundary now, like when people talk about agriculture, people want to capture the field management history, which means you might have, like a field boundary, like capture time period. And I think that is missing from the metadata.
From the core specification.
Yeah, from what you're showing the properties.
Right, so I think that there's been some discussion about a more extensive extension that will describe more of the life cycle. I was not involved in those discussions. I think that, in the ML one, we try to keep that quite simple. So maybe not as expressive as what's needed in general.
Yeah, I mean,
Yeah.
we also didn't dive super deep into it because it's worth a very deep dive. So I think I would love to have you not like on a working group of like, what do we do with time? And yeah, what we decided in the core, a lot of the thinking in the core was what about all these people who don't put any time in? Do we want them to not use this because we haven't put time in? Another one was, if there's just the year, like, is it useful for that to be in there? And where we got to was like, it's good to have one time in there. And we use this observed time as like one, but it's optional. So like, we're not requiring it, so we don't get bad data into it. But the main thing is like, we need a much richer vocabulary to express time. So that will be a sort of kind of work, and the core can change too. It's not to say that that's set for all time, but it was like, we should just have one time value in the core to indicate that like time is very important to us.
One thing I'll say, I'm not sure if I interpret the question in the same way, because there's one of them is about the life cycle of the field, and you could argue that like that's an entire data model. This is not something that exists within a geometry, but like evolves in parallel to geometry. And so you don't necessarily have to represent everything inside this feature, GeoJSON feature.
Yeah.
And that especially is true if you're talking about, tell me the history of all of the nutrient applications to the field. Like, this is not a flat structure. This is most definitely kind of like a hierarchy or even a graph.
Yeah.
And so maybe it's a scope question. Like, there need to be standards for those things, but they might not belong here.
Yeah.
So I'm sorry, so I cut the conversation halfway, but I'm gonna interject anyway, because I think this use case, we've dealt with it a lot in the aviation world, and we have in the OGC the concept. It's not an OGC, it's an ISO concept, which is like time slices. And we have a JSON schema for that. So I wonder if we can learn from that, which is the status of the airport runways and the lights, not the actual flight positions, which are way more dynamic. But maybe that's a model to be inspired by.
Yeah, certainly more work needed. And yeah, I think, yeah, we also had lots of discussions about like, yeah, assuming a very simple model, we know it's much more complex. So at the very least, we'll have a language to talk about things. And we probably need a lot more work. The other one that we talked about at Planet, and I'll pass to you after this, is like daily time series. You're not going to shove a daily time series of soil water content into a single thing when it's, 1,000 days over even just 3 years. So I think there's something we want to tackle and think about of how do we represent all of this tied to the field and what is the right set for that. Ariel?
Yeah, maybe it's not the right time, but to follow up on the date, there are many operations that like planting date, harvest date, that is not one date. That is like a window, because it might take more than 1 day to harvest a field or to plant a field. So I just want to raise that issue now that we're talking about dates.
But it also looks like we have a group that wants to continue discussion.
Yes, I wonder if you could pop in the chat there, because you had created a link for an issue for the time extension.
Yeah.
Would that be a good place for people to jam?
John? John?
Yeah, I really agree with Johnny. Thanks. Actually, I just figured out how to raise the hand in Zoom, so maybe my question is partly covered before.
Cool.
But I still bothered by some use case I'm knowing. So if we define a field, how we consider about this can be split. So because we know 1 years they have a field, but they have some different practice within the field. So it looks like 2 fields. They have different crop type and different practice. But some other day they decide to merge them together, or even merge into the neighborhood field together. So I just wonder, do we say this one can be somehow covered by the current specification?
I mean, I think the current specification, no, like it's more of a language about stuff. I mean, a lot of the stuff Andy was talking about for Varda is thinking deeply about that problem, and the specification would help interoperability of some of this. And yeah, maybe this provenance or history or tracking through time could be something, but yeah, right now the specification is more just a common way to talk about properties having to do with fields. So, but I mean, it's also, we're forming this community to tackle these problems. That's clearly is a problem. So
yeah, if you want to know like how we tackle that problem inside of field ID, which I think you have to have some other infrastructure that knows about things and relates them outside of the individual objects themselves, because these are relationships. not static properties of fibers. But I can talk to you about it. I can explain how we do it.
Yeah, let's do that offline and get through this, or maybe we'll have a little extra time, but.
Okay, send me an email, Allison.
Thank you, Nathan.
Thank you.
So I'm going to present our work on taking really a deep dive into how, if you have a benchmark data set of field boundaries and associated imagery, how can you train machine learning or AI models with those? So we really took and relied on the data set that Hannah presented yesterday, the harmonized ASU field boundary benchmark data set covering 25 countries. There's around 10 million ground truth polygons. All these are sourced from the public domain. Not all of them will be eventually released and having paired imagery with growing season and planting season. And the question really was, can we get this into a FIBOA-ish type structure, build a PyTorch dataset object that can consume that, and then train some semantic segmentation model to segment each pixel in the imagery as either a field or non-field. So zooming into the South Africa split from this dataset, you have multiple layers of imagery. All of the field boundaries, there are around 11,000 in this particular crop. And then for machine learning training purposes, we want to kind of grid these up into individual patches. And here we need a schema, maybe at the collection level, that says for each group of the field boundaries that fall within one of these grid cells, what is the URI to the imagery that covers that set of field boundaries. So we don't have an actual extension for this, but the idea is to make an extension that allows you to specify that as well as all of the other types of metadata that Nathan was describing. So for machine learning people, we really want something that looks like this, a dataset object that we can instantiate, this pseudo Python code with the path to the FIBOA dataset on your machine, maybe it's a cloud resource, saying something that you want to filter by, like country name, and then either a training and testing split. And then once you have this, pretty much any kind of machine learning researcher will be able to take this and go play with the latest and greatest models, transfer learning from all the foundational models that are coming out, and really try to tackle this problem of how to automatically delineate fields from satellite imagery with a consistent training and testing set that has global coverage. And we did this. We translated the South Africa data set to a FIBOA-ish type representation. Didn't really follow schema, but we have a bunch of different features. We have collections that have pointers to the imagery on our local machine. We trained a model using this setup. So 2/3 of the data in South Africa, and then validated that model on a 1/3 held out test split. And here you can see the predictions and what the val mean IOU looks like over training time. So for one of those individual grid cells, we have image at time point 1, image at time point 2. This is again planting in the harvesting season. The target, so what we're getting out of all of the individual features that are going along with one of those grid cells, and then the output of the model after training. So it's never seen this imagery before. It's doing inference and producing this. Here are a couple more examples of what that looks like. Here you can see that it's actually, even though it's not supposed to be getting these, is that a field or not a field in the imagery? I'm not sure. It's doing something correct. I know you can't see this online, maybe. And that's what we have. So this is going to be released. We'll take this on as a to-do over the next couple of weeks of formalizing this in TorchGeo, which is a Python library that allows you to kind of interoperate with geospatial data. And then if you have a FIBOA dataset, if you know which imagery was used to create that dataset or imagery that you can collect from where you know those field boundaries are valid in time, you can then plug it into a training and testing pipeline, as well as releasing the benchmark data set as a FOBOAized data set. And that's all I have.
Questions?
All right, Caleb, I know we've talked about this before, but like, you said, the assumption is that the data set's gonna be available locally, but you also sort of offhand said, or in a cloud resource. Could you expound on that? Like, is there any difference you see in terms of like how the data would be stored or documented?
Yeah, I mean, it should go on source co-op if,
I wasn't asking. But I'm just curious, like functionally from because I don't understand like PyTorch. Like how different is it?
like, the actual data loading is done with REST-IO, which doesn't care.
It doesn't
compete all, whether something's a, web URL or local disk.
So are the patches of the sizes in image training samples, they are already defined, the sizes?
Yeah, in this benchmark data set, yes. I think, and we should still discuss this in a working group, the extension schema that allows you to define a benchmark data set, that should be totally flexible. So it's just a collection of fields with some bounding box that has paired imagery that you can use to train and test them on.
Yeah, I think it's, because some of the issues we discussed in our group is like a desire to be more flexible about the patch sizes. And I wonder if, or it's already a function that is already in TouchGeo that you can actually generate the patches on the fly with the specific bounding boxes or the patch size from a big raw internet images like we can generate.
Yeah, we didn't talk about that, but that also should be possible. And you might not even need like a benchmark type extension. You might just need the ML extension. For
Yes,
that.
yes.
So if you have a FOBOA collection, if that follows the maybe just ML standard, then you're going to basically have a vector data source that you can pair with imagery that will automatically know about what time it's valid for. And even other things like how it was collected.
Any questions online? Got a comment online.
If I had like a drone take images of a field, would it be easy to add those images in if we had our own private little data set, or would it be difficult to do something like that?
I think it would be easy. It would just, for the benchmark data set, it's stop sharing. It's just like all those different grid cells, those would be collection level objects. And they would have they would have a property that points to a list of imagery for which cover that grid cell.
So you just include it in that?
Yeah.
Okay.
I mean, you'd have to do some work up front to make sure that the imagery is covering the correct grid cells, but after you do that, it should be fine. Other questions?
There's a comment online. Great work, Caleb, to work this out in such a short period of time. From Nana.
Thank you, Nana. Good to see you.
Sheila.
Great.
Awesome. I think that's a wrap
That's a wrap of the workshop.
of this session.
Okay.
It's now source cooperative. So more source. Who's new? Like who didn't hear my spiel about file systems? Yeah. I don't repeat. Remotes, you're welcome to continue to join. We'll leave it on.
Do you want to give people 5?
Yeah, we have 30 people. Cool. We'll be back in 5. Remotes, feel free to stay on. But thank God.
No, it's very helpful.
Good. I got more.
Yeah. Just took a while to get there.
Yeah.
Rescue for the board. Yeah.
Yes. First off,
I'm impressed to see how quick it comes together. That's because you're all very smart group with the right tools, but it's encouraging to see.
My next week.
Yeah, we're so limited coffee and sugar outside, for the candy bags. That you get some problems.
Good job.
I have a flight at 4:30. I'm nervous about airports.
You're going to
Where we flip around, this time, industry or community, and then the workshop. I think we'll flip around and do the workshop. Yeah. And I think
It's very great working with you. Great working with you.
we catch up again.
Yes.
I think I'm gonna have to go to the airport.
Okay, he is too, so I want to make sure. You're okay. As soon as I can. So I really hope we can keep the collaboration going and get through to work with you.
Thanks for having me.
You're not leaving yet, are you?
No, we really should. Come on. I mean, when I started this much.
No.
Please go.
Kolkata
is like on the eastern, northeastern side, almost like near the Bangladesh. And Pune is like.
Field boundaries.
Sorry.
How it gets there, I don't care. If I can see the numbers on the.
Again, my.
Your story.
Oh, yeah, it's crazy. But I have my wife and kids, so she could. Yeah.
Yeah.
So how does it work?
Yeah.
It just sort of naturally, we
Perfect. Yeah, sure. Assistant professor in Junior Student Punjab. So I'm here on 2 years leave. So just to dive into this story, like a kind of sabbatical. Unpaid leave. Yeah, kind of that.
Andy. Sorry, I was cheap.
Yeah.
But thank you.
Yes, are you on like LinkedIn?
So let's.
So what I kind of missed that when you were saying about what you intend to do also, like person to the workshop. So I don't know if I can kind of justify like flying over. But how frequently we doing these things?
For sure, we'll do one every next. It's like.
Okay.
For this initiative, I set aside a travel stipend budget.
Very excited to see that.
Yeah.
What you need to be able to.
We'll see. That's not sure. It'll really get there, but.
So we can just all go.
I was more optimistic. Certainly. Right.
Because there are some things that kind of like, the team has just got like a folder of stuff, and if I go and it's happening sometimes because they just add stuff. They're like, oh, but can you just quickly do this, you know, and like sometimes you have someone that just knows how to do that stuff, like, look, this is what you do. So you know, like somebody else who's watching you know, to.
I love visualization, geovisualization
Stuff again, and sometimes it's best someone that knows exactly what's going to be used for this. Things like
never
that.
been
So,
there.
yeah,
That's
that's something
something
we can discuss. And also the whole governance stuff.
Yeah. and that
It's
is-
also, yeah,
We're comfortable.
get really expanded. really
We're trying to
quickly.
keep it. the whole-
Yeah.
So.
But it might not even have some people organizations, there are certain people who have something to, that might be very involved in something like that.
Nice to meeting you. Thank you. We'll meet anyway.
I think I'm thinking you have because I have.
Yeah, do that.
Yeah,
That's the plan, right? Nice to meet you. That's the plan, right? I'll,
Well, the job, so like,
have any barriers?
you know, the possibility to solve it, right?
The company can be a feeling like this year or next year, they will just figure.
Sure.
Yeah,
Yeah.
you know.
I mean, we have to do it.
You can tell him we're leaving.
Oh, okay, you guys.
Hi, I'm Marge. Nice to meet you.
Okay.
Yeah.
It was just, it was so neat. I was still in the army down there.
Here, are you heading to the airport? Thank you so much. He was telling me.
It really did. So safe travels home and we'll circle back next week with Dr. Brenner.
I'm like, what a small world.
Yeah.
Isn't it?
Amazing how like.
Hey, how are you? Good.
Well, then we're 2 hours away and I was there. Safe trip. Safe trip.
Yeah, it's good to be on the actually, I'm going now as well.
Have a good trip back. 2 hours.
It's all right as well.
And now here is like tomorrow.
I don't know if the guys were at the building today, or today, they're doing the whole. I know, I think the building.
Do you know Jet?
That would be great.
Yeah. Well, I need to double check.
So he was actually.
Yeah.
So yeah, then he went to AWS.
That's what I, you know.
Like he helped us like design. So many conversations. with different
Are you heading out?
people with the band. It's Microsoft. You know, there's, it's always been like, he's got help me design it, like, we must be able to find a way for you to use it somehow. But it's always been really good, like.
Maybe our guys are doing the criteria.
Someone in there.
I really don't know. But I
Oh, no,
thought
it's pretty good, if you can just do this and.
Yeah.
Did you hear it?
We find out that we-
Yeah.
We're the last people.
Yes. And it's amazing.
Cold runs into water.
So stay in touch.
Only through like, it's the whole thing hot and now it's gonna be cold and I know that they're in front and they're
So yeah,
running
hit me
each
up.
other out.
Yeah, with, I mean, so many different people within there, sometimes hard to describe, really, you really own, like, it's in the background, I don't know, how to place it, you know, trying to, I mean, shaking on
Travel safe.
Yeah, I think so.
I think most of it I wanted to still get over yesterday. I have a personal word to those things.
Lots of groups that
We already kind of work with it in different ways, but it's like.
Yeah, it's, they can't be cured, but there's a way to live with it. So you gotta
Yeah.
take off.
well,
Okay.
should stay for a bit longer, but I think
Okay.
I'll invest in trying to get that.
You've gotten your fill. So, and I'm,
But I mean, definitely there's some kind of some practical like things that they should be doing this.
spray the trimmer, we'll spray the water.
And so I think it's,
Yeah, I'm happy to talk to you.
So maybe. The deep dive is like, you know. Like the data sets.
Yeah.
It's like.
Were this the dreams? Did you cross that water?
Figure out.
Yeah.